Good evening, minions. Welcome aboard to the next session, session number 2 of capacitors. Last lecture, we have seen what a capacitor is. It's nothing but an energy storing device. And you can store the energy via charging using a battery, and you can again utilize that energy to light up a bulb or run a motor or anything else. And we have calculated the energy stored in a capacitor to be half CV square or Q square by 2C. We have also calculated the charge stored on a capacitor for a potential difference V to be Q is equal to CV. We have also seen the different types and construction of capacitor, the spherical type, which were like momos, and then the isolated one, which was gulab jamun. Then we have also seen the roll type of capacitor, which was a cylinder. And we have also seen the sandwich, of course. What a lovely way of looking at capacitors. We have also seen what is the field inside a capacitor. And today we are going to do a lot of questions where capacitors are going to be combined. So now that we know how a capacitor works, what is a capacitor, what's the energy, what's the field, what's the potential difference, what's the charge, etc. Now we are going to see a lot of capacitors in combination. And you would have seen in these printed circuit boards or in a computer or on a washing machine or inside a TV or other electronic or electrical gadgets, you would have seen these circuit boards. So it's a combination of lot of things apart from capacitors, but still let's lay the foundation today for studying how to combine capacitors with me, Shreyas, your master teacher for physics, going live on this channel, your anchor. Welcome aboard. What a lovely evening it is. So today we are going to have a lot of fun, guys, and remember we have studied combination of resistors, so you're going to see a lot of similarities in combination of resistors and combination of capacitors. So in case many of you are new over here, so I am Shreyas, I teach physics and I love physics and I also love teaching. So that's why I'm here, and I have been teaching for almost a decade now, and I have produced some amazing ranks, and I hope that you coming over here is also going to help you, it's going to benefit you, and that's what JEE Enthuse is for. It's a English channel for all the students who are aspiring to clear the JEE exam, the Olympiads, the even the NEET for that matter, or even the board examinations. So welcome aboard. Hello Naga, Ranjit, 17S, Aishwarya, Aarti, Khirito, Sans Priya, Prajwal, Jumna, hello Sneha, hello Ankit, hello everyone. And what a lovely evening it was yesterday, and I met so many of you in my live stream on my Instagram. So in case you do not know, I also have an Instagram account, Shreyas_Vedantu. So you can follow me over there for cool interactions, videos, motivation, and so many other things that I keep posting. So it was very lovely actually to see all my students out there. I went live with so many students, so it was fun. I have not shared the video, so guys, if you miss it, I don't think you will be able to see it. So it's okay. Next time, I hope you will be able to catch me live again on Instagram. Hello Krishnaveri Payal, hello Fida, hello Fahim, hello Princey, hello Shubhangi, hello Saurav. Welcome, welcome, welcome Princey, welcome Pranuti, welcome Ira. Yes, I'm glad all my minions are here. And guys, if you want to become a minion, it's very simple. If you're not a minion yet, then you know what I mean. So you just need to hit the subscribe button down there. So just hit the subscribe button. That's how you become a member of our family. And if you're already here and if you're a true minion, you know what you should do. You should smash that like button down there. Only then I'm going to get the energy to conduct this session. So go ahead, smash that like button if you have not done it already. And also subscribe to this channel, because only then you'll be getting all the important updates and the notifications. So let's get going, guys. And today we are going to start with capacitors in series. Remember, we have talked about resistors in series. So today we are going to talk about capacitors when they are kept one after the other. That kind of an arrangement, like the one shown over here, is said to be in series. So they are kept one after the other. And what happens in capacitors in series, we'll see that in a bit. But you can always write both these capacitors into one single capacitor. That capacitor, I call it as the equivalent capacitor. And then the equivalent capacitance CS strangely has a different formula. Okay, so remember it, 1 upon CS is 1 upon C1 plus 1 upon C2. So the formula for capacitors is exactly opposite to the formula that you have found in resistors. So that's something you should keep in mind. So this is the formula that you should keep in mind for capacitors. And you can also take LCM and you can simplify it, and you can write it as CS is equal to C1 C2 divided by C1 plus C2. This will also work if there are two capacitors. And by the way, this formula will extend if there are more capacitors, like 1 by C3 plus 1 by C4 and so on and so forth. Now, what is same and what is not same in these capacitors? So let's talk about it. So imagine the equivalent capacitor has a voltage difference of V. Then these two capacitors naturally, totally should have a voltage difference of V. But what will happen for individual capacitors? Well, the voltage difference won't be V. In fact, it will be V1 and V2. Understand that. This capacitor has voltage drop V1, that capacitor has voltage drop V2. In fact, V1 plus V2 will be equal to the total voltage drop. So voltages get divided. Understand that. Now let's talk about the charge. So if this capacitor has a charge of Q, okay, if this capacitor has a charge of Q, just like the current flowing in a resistor is same, the charge on the capacitors will be same when they are in series. So keep this in mind. So here, if you write Q, here you should put minus Q, here you should put plus Q, and again you should put minus Q. So the charges, no matter what the capacitances are, keep this in mind, the charges are always the same when the capacitors are arranged in series. Now, one way to look at this concept is, if you pay attention closely, you will realize that this part, look at this one which have kept inside that blue part over here. This is an isolated system. It's not connected to the outside world electrically. Now think about it. The total charge on this part should be 0. Why? Because there is nothing which can come inside it, nothing which can go outside it. So naturally, if this has minus Q, this should have plus Q amount of charge. Now, if this has minus Q, naturally the opposite plate must have plus Q. And if this has plus Q, naturally this plate must have minus Q charge. That's how we can prove that the charges on all the capacitors are same using the principle of conservation of charge, nothing else. So conserve the charge, the total charge inside this blue diagram is 0. So if this is plus, this should be minus, vice versa. And opposite plates, we know they always have opposite charge but of the same magnitude. So that's why the charges are the same. So I'm going to write that down. Q is same for all the capacitors. Now if you recollect, Q was also equal to CV. Q was also equal to CV. That means the voltage drop is inversely proportional to the capacitance. If something has more capacitance, the voltage drop across that capacitor in series will be less, because they are inversely related to each other. Inversely related to each other. Alright, so that's how it is. Very, very important. Now let's play around with it a little bit more. I hope you have written down all these things. Very, very important notes. Welcome Ira, welcome VK channel, welcome Hoin, welcome aboard. Join in. Yes. So you can see that just like the equivalent resistors in parallel has a lesser resistance than individual resistances, the formula is the same. So that's the reason why the equivalent capacitance in series has less capacitance than individual capacitors itself. Okay, so that is very, very important. Ankit, so that's the reason for that. You can look at it formula wise, right? So just like the formula for resistors, so same way the equivalent capacitance has lesser capacitance than the individual one. Okay, now another important thing that you should notice over here, let's say some values were given. Example guys, example. Let's say this was 5 volt. So total voltage drop is 5 volt. And let's say this was a 2 farad capacitor, and let's say this was a 3 farad capacitor. Now by logic you should be able to think guys, this voltage and this voltage should not be the same. In fact, the voltage drops across this and this should be in the inverse ratio. I just told you, voltage is inversely proportional to capacitance in series. So divide the voltage in the ratio of 3:2. So voltage across 2 farad and voltage across 3 farad will be in the ratio of 3:2. How do you divide 5 volts in the ratio of 3:2? Obviously, this should be 3 volts and this should be 2 volts. That's what you will get. Now, if somebody asks you, what is the charge on each capacitor? Well, that's very simple. The charge on this will be C into V. So 2 into 3, which is nothing but 6 coulombs of charge. And the same charge will also be there on this capacitor. So that charge obviously should be C into V, which is again 6 coulombs of charge. So you can see the charges are the same, but the voltages are definitely different and they are inversely related to the capacitances. Yes, physics lover, it will be if capacitance is there in your ICSE syllabus. Alright, now let's go to the next part. Okay, now that is parallel, capacitors in parallel. So the capacitors in parallel will be arranged parallel to each other in different branches. You can clearly guess what is same in all of them. The voltage difference is the same, and you can always convert it into one single capacitor, which I call it as the equivalent capacitance over here, CP. Now the formula is again quite opposite to that of resistors. So for parallel, use the formula of series in the resistor. So CP will be nothing but C1 plus C2. So the formula that you have used for series resistance. And in parallel circuits, what will happen, guys? The voltage drop across all capacitors is nothing but same. And using another principle which says Q is equal to CV, that clearly implies the charge is proportional to the capacitance. So the one capacitor which has more capacitance will also store more charge for the same voltage. So that's how the charge is directly proportional to the capacitance. So that means, guys, that each capacitor will be storing different charges. This will be Q1, this will be Q2. This is minus Q1, this will be minus Q2. That's the opposite plate. On the equivalent, please keep this in mind, the charge on the left plate, think both these plates were merged together. So it will be Q1 plus Q2 over here, and here it will be minus of Q1 plus Q2. Okay? So that's the charges which will be there on the left plate, on the right plate. That's very, very important. The charge on this plate is the addition of all the charges on one side of the plate. Very important. Okay, so Shreyas, just use HC Verma. That's enough. HC Verma or Halliday-Resnick, that's more than enough. Okay, fine. So now let's take some special values and see how this works out to be. So let's take some special values if you have made some notes. So imagine this capacitance over here was, let's say, I don't know, again 2 farad example, and this was 3 farad. Now the equivalent capacitance will be just 2 plus 3, which will be nothing but 5 farad. So the equivalent capacitance is going to be 5 farad. Now let's say I apply a voltage of maybe, I don't know, 10 volts. So you apply a voltage of 10 volts. So each capacitance will get a voltage of 10 volts, undoubtedly, because voltage is always the same, but the charge will be different. Q1 will be CV, so 2 into 10, which will be 20 coulombs. Q2 will be C into V, which is 3 into 10, which is nothing but 30 coulombs. But the charge on the equivalent, that will be 30 plus 20, so that will be 50 coulombs charge here and minus 50 coulombs charge here. That's how the charges get divided. You can see the charges are divided in the ratio of the capacitances themselves. Very important. So that's how you solve problems. So problems are going to come up now. Let's get going. Okay, now you must have understood how to solve these problems. Excellent. Let's get going to some problems, guys. And here it comes. What is the equivalent capacitance of this circuit? Options are there. If you have attended my current electricity classes, this is a cakewalk for you. Come on, guys, you should be able to do it. Quickly calculate. Think about it. What's the equivalent capacitance between A and B? Post the correct option in the chat box. Post the correct option in the chat box. All right, all right. A lot of people saying, yo, thumbs up, flames. Yes, come on, come on. Yes, Daniel, you can definitely use this for NEET. The theory is the same, guys. People ask me, sir, can I use this for state board? Can I use these JEE Enthuse lectures for NEET? Can I use this JEE Enthuse lectures for ICSE? Guys, you can use it for anything because subject will never change. Only the pattern will change, the marking scheme will change, the nature of the questions will change. Theory will be the same, the difficulty will be different. Yes. A lot of you are saying B, some of you were also saying A, either B or no. Ankit, you cannot give me options. You are not the examiner. Okay. Okay, let's see. So the correct answer, guys, is option A. Well, now let me tell you why it is option A. Now this type of arrangement is a very special type of arrangement, and if you have realized it, this is this arrangement, disguised form. You just have to remove the mask, you have to see it clearly, and you'll realize it's actually a very simple circuit. How? Look at this. If I mark these points as P and this point as Q, then you can redraw that circuit, guys. From point A, okay, from point A, you have this capacitor like this, and it goes till point P, but point P is same as point B because there is a wire over there. So this point P is same as nothing but point B, obviously. Now from point A, there is a wire going towards point Q. Okay, so there is a wire going towards point Q, and at that point Q, you have a capacitor connecting P and Q. Okay, so between P and Q, again you have a capacitor. All right, so this was C, this was C. And the last capacitor is between Q and B. So between Q and B is the last capacitor. So just put it across like this because the same wire is only going to go to B. So this is a third capacitor. What are they in? They are in parallel. Now if they are in parallel, guys, the equivalent capacitance will be C plus C plus C. A lot of you forgot the formula. Guys, it's a capacitor, not a resistor. So it is 3C. Understood? Yes, simple. But I think some of you use the formula for series and you got the wrong answer, guys. So when they are in parallel, please understand it is not 1 by C plus 1 by C plus 1 by C. It is C plus C plus C. It's a capacitor. Be careful. Alright, chalo, no problem. Let's get going to the next question. I hope you're going to do the next question properly. Here it comes. So, what is the equivalent capacitance for this situation? Now again, if you have attended my current electricity chapter questions and you know all the Menti quizzes and the theory sessions, you will see this problem is very easy. Come on, what's the equivalent capacitance between A and B? Be careful, do not mix up the formulas for series and parallel. Yes, it was disguised. Yes, don't worry, be careful. It's very simple, guys. Think about it, you can do some trick. There is some trick, very simple trick, and it becomes very easy problem. Actually, it is very easy problem. Come on, come on, come on, come on. All right. I'm not sure, Ankit, why comment review came. Don't worry about it. All right, come on, come on, come on. Arey, don't worry, 17S, this is very simple problem. If you have attended my session on current electricity, this is very easy. Yes, the correct answer is option C. Many of you have got it. Very good. Very good, JEE enthusiasts, very good minions. Now you'll be like, sir, how did this come? Remember this very famous scientist I told you about. Who was he? Wheatstone. And I told you about this very special arrangement, Wheatstone's bridge. Yes, that circuit is a balanced Wheatstone's bridge, and it works even for capacitors. Just that you need to check whether the capacitors are in the ratio. This capacitor and this capacitor are in the ratio of 1:2. This capacitor and this capacitor are also in the ratio of 1:2. Now whatever is there in between them, it could be a capacitor, it could be an inductor, it could be another resistor, it could be a battery, it could be, I don't know, it could be a donkey also, doesn't matter. Whatever is there, you just remove it, guys. That's it. So just remove it, and now it looks like a very simple circuit. So it doesn't matter what is there in between. That's it, neglect it. Now these two are in series. These two are in series. So their equivalent will be C into 2C divided by C plus 2C. Parallel formula. Remember, for series use the parallel formula. Correct. So this will be 2C by 3. Similarly, the equivalent of both of them, what will it be? 3C into 6C divided by 3C plus 6C. 3 6 are 18, 3 plus 6 9, so 18 by 9 2, so it will become 2C. Now 2C by 3 and 2C are in parallel, so the equivalent combination AB will be, because they are in parallel, just add them. Remember, it's a capacitor, so 2C by 3 plus 2C, and that is going to give you 2C plus 6C by 3, which is nothing but 8C by 3. That's the answer. That's the answer. So Sonal, basically in my current electricity sessions I explained that in a Wheatstone's bridge, whenever resistors are in a particular ratio, whatever is there in between you can remove. So please attend that session after this session, no problem. So here capacitors are in the ratio of 1:2, 1:2. So whatever is there in between can be completely omitted. You can remove it, you can forget it, nothing will flow through it. It's a useless thing. So now the moment you remove it, you can see these two are in series, these two are in series, and their combination is in parallel. Alright, I hope now, Sweta, you have understood this. So guys, you should have some knowledge about resistors, the previous sessions, only then probably you will get some hang of it. And even if you are not attended, don't worry. Try to understand as much as possible. You will slowly get the hang of it. So VK channel, now it will not be visible, okay, because I have not posted it. Okay, I hope now it's clear. Yes, Wheatstone has helped you. So remember guys, whenever things are in a ratio, you can always omit it, and that's nothing but Wheatstone's bridge. That's what I told you. In a Wheatstone's bridge, basically, you know, you can always remove whatever is there in between. It works for resistors, it also works for capacitors, it will also work for many other things. Remember that. Okay, are you guys now ready for the next type of question? Okay, yes, resistor is like the brother of capacitor. Now for the next type of question, I am going to give it to you as a homework. Now you can guess what kind of question this is. You have solved this question in resistors, but I don't want to waste time over here solving the same type of question again. So this will be your homework question for today. And if you want to know how to solve this question, please again rewind back to my resistors combination session in current electricity. It's there as a playlist. So please watch it and you will get the idea of how to solve this question. Figure this out. That's your homework. Let's see how many of you post the answer in the comment section, not in the live section after the class ends. Okay, so that's your homework question. Now you'll be like, sir, are we going to repeat all the things that we did in resistors? What is the different thing then? Yes, so now we are coming to that part of the lecture. Now that part of the lecture where you're going to see that once you understood the basics of combining series and parallel, understanding that whatever you have studied in resistors can be directly applied. The symmetry method, the connection removal method, everything can be directly applied. There will be something which is different in capacitors, and that's what you are here for, and that's what I always do. We are going to solve some complex problems now. They will involve both resistors as well as capacitors. You'll be like, so what? We know how to solve resistor, we know how to solve capacitor, but there is a small catch, and that's what I want to show you. Okay? Yes. Himalaya, even for inductors you can do it. Yes, even for inductors you can do it. Not a problem. It's the same thing. When I teach you inductors, you will see that. So before doing that, let me tell you, for all the 12th standard and the dropper students who want to study under me or teachers like me for the crash course to prepare for the upcoming JEE Mains examination in the next 2 months, there's a crash course running for you. Every Monday that crash course starts. That crash course has amazing teachers whom I know personally, and a lot of my students have already joined it. Now, what are the benefits that you get? See, it's not a usual crash course. The reason why I'm saying that is because you get 120 live sessions, which are two-way interactive sessions where you can interact with teachers. There are quizzes, there are hotspots, there are polls, there are leaderboards. There is a class teacher to solve your doubts inside the class. And after the class also you get teachers to solve all your doubts from morning till night. Very important in the last few months to clear all your doubts. Also you get 10 full syllabus practice test series with All India ranking, and 10 part syllabus test series again with All India ranking, guys. So you'll be competing with the genius minds of the country so that you get to know where you stand. You get analysis reports, everything, and there will be some special sessions by our guest lectures for the tips and the tricks to crack the JEE Mains examination. Now you'll be thinking, okay sir, now you're giving so many benefits, so there will be a very good cost to it. Well, the cost is only 10,000 rupees. But let me tell you, the cost is actually lesser than 10,000 because you are attending my class today. So you'll get 20% off and you'll get the course only for 8,000 rupees. That's very, very nominal considering this course will be running throughout, you know, January, February, March, April also till your second attempt of JEE Mains examination. So how do you register for this course? There is a link in the description box. Open it, read everything properly, and then you can register for the course. And do not forget, the coupon code has to be applied. Only then you will get the discount of 20%, or else you won't get it. So use the coupon code SHCC. That's the coupon code. Alright. So I hope I'll be seeing many of you in the crash course, which is very, very crucial for cracking your JEE Mains attempt. Alright. So let's get going to the different type of questions now. Capacitors with resistors. Now I'm going to tell you a beautiful trick. After this, you will never break your head. Everybody must be now slightly confident about series and parallel. Solve more problems. Understand these sessions by me are here to just push you to get to those problems, to give you that idea. Okay, see, this is doable. This is how it has to be done. Now it's up to you to practice all these problems at home. And I'm pretty sure you're going to do that. Now, whenever resistors and capacitors come, something like this, there is a very simple trick. The trick is, when capacitor is already charged, the charge is already accumulated on it. That's it. There is no more change in the charge. So the current flowing through that capacitor will be zero. Capacitor will block the current once it is charged. We can see there is no wire connecting the plates. That's it. After it charges, there is nothing which flows through it. So the current flowing through a charged capacitor is always zero. So that means, if that's the situation, you can always convert that capacitor into an open switch. What is an open switch? It blocks the current. So this is no different from this circuit. These two circuits are equivalent. We can just break this apart. That's it. So that is the trick to solve the questions. Just keep this in mind. Just keep this in mind. So now, if this is understood, now think about it. Just think about it. If I give you some complex circuit, okay, if I give you some complex circuit like this, and I label this branch as 1, 2 and 3, and this is connected to a battery. Okay, this is connected to a battery. Guys, think and tell me, the current from the battery, this I, do you think it will go in all the three branches? If so, let me know. And if it doesn't, tell me which branches will it go from? Which branch do you think this current will go from? Come on, think about it. Papi Reddy, magnetism will be obviously after capacitors. So think about it. 1, 2, 3. Which branch do you think it will go from? Do you think it will go from any of the branches? And if it goes, then think which branch will it go from? It will not go through anything. Kirito says only 2. Some people are saying, Science Priya also says only 2. Think, there is a capacitor here, guys. This will block the current. This will block the current. Here, there is nothing. So the current will come like this and it will go nicely through this branch. Understand that. So the current will only go through this branch. Now, if it's not going through any other branch, think about it. What is the total resistance of this circuit, guys, when the current is going? The total resistance is just R. Only one resistor in the circuit. So what will be the value of current? It will be just E by R. That's it. It will be just how much? E by R. Nothing else. Nothing else. I hope this is clear. I hope this is clear. Everyone understood this? Now, if you have understood this, also understand that in this same circuit, where there is that battery, you had a capacitor and a resistor, and then just a resistor, and then just a capacitor. Guys, think about it. If the current is only flowing through this part, okay, only the current is flowing through this part, nothing else, there is no current here, no current here. By the way, what will be the voltage difference across this capacitor? Can you think what will be the voltage across this capacitor over here? Come on, think about it. What will be the voltage difference across that capacitor? I feel it should be E only. Whatever is that EMF, it should be the same voltage across this capacitor as well. Now, if that's the voltage across this capacitor, and now if I ask you what is the charge on this capacitor, what will you say? Oh, the charge. Yes, that's going to be C into E. That's it. That's going to be the charge on this capacitor. So it's not going to be 0, guys. Think about it. The same voltage difference will be there here also. This is just a wire. You might think no current is going, but it's okay. Even if current doesn't go, there can be voltage difference between 2 points. Think about it. This point has the same voltage as this point. This point has the same voltage as this point. This point has the same voltage as this and this point also. And these points all have the same voltage. They are all in parallel. Realize, the moment you realize they are all in parallel, that's it. So it's charged, and that's why there is a potential difference. See, potential difference can be created by numerous ways. Battery, resistance, capacitance. So here the voltage difference is because of the charged capacitor. Here the voltage drop is because of the current flowing through the resistor. That's how it is. I hope this is clear. I hope this is clear. And what do you think the voltage difference here will be? What do you think the voltage difference between these 2 points? It's still going to be correct, but there is another thing over here. If I ask you now what is the charge on this capacitor, now you'll be like, sir, now there is a resistor, what do I do? Guys, don't worry. Is there any current flowing through this branch? This branch number 1, is there any current flowing through this branch? Yes or no? Is there any current flowing through this first branch? Yes or no? First branch. In the first branch, is there any current flowing? Think about it. No. Why? Because there is a capacitor. What does a capacitor do? It blocks the current completely. So there is no current flowing through it. So if there is no current flowing through this branch, think about it. Won't there be 0 voltage difference across the resistor? Think about it. No current flowing through the resistor. So what is the voltage difference? 0. So if there is no voltage difference, this point and this point will be at the same voltage. Yes, this point and this point are at the same voltage because there is no current. IR is 0. V is IR, I is 0, then V is also 0. So if I ask you what is the voltage across this capacitor, what will be the answer? The voltage across this capacitor is still E. So if I ask you what is the charge on this capacitor, what will be the answer? C into E. Q is CV. That's it. That is the answer. I hope this is now understood how to solve the problems. We are going to take up a problem so that understand, let me tell you, it's not easy problems. None of the problems that I'm going to take are going to be easy. They are going to be mains, advanced, mixed combination, but it will clear your concept. So push yourself, try to understand, use your brains, think properly, you will get to it. Okay, so let's do some good questions. So here it comes. This is your first question. Find the charge on the capacitor and the currents in the branches. Okay, lot of things are there. I know you might get slightly psyched, but don't worry, there are more complex questions and you will see that there is a very easy way to solve these questions. First thing, what was my trick? Wherever there is a charged capacitor, remove it. So which are the capacitors? Two capacitors are here. Remove them. How? Like this. Convert them into switches. So this branch is useless. This branch is also useless. I hope this is clear. These two branches are useless branches. No current flowing through them. Now just think, how will the current actually flow? How will the current actually flow? If it comes from here, this current will go like this. Do you think any current will flow from here? No, because there is an open switch. So this current will directly go like this. Now from here, it cannot go here because there is an open switch. So where will it go? It will go here. Then it will go here. Okay, it can't come here. It will go like this. It will come like this. And it will be back inside the battery. Okay, so there is only one loop across which the current is flowing. Nothing else. Only one loop. That's it. Now, what is the total resistance in that loop, guys? Think about it. What is the total resistance? I think I encounter one resistance here and other resistance here. So what should this current be? This current should be E by total resistance, which is 2R. That's the current flowing in this branch. Correct? I hope everybody is getting it now. Now we have found out the current in the branches. Every branch, you tell me a branch, I know the current. If you ask me what is the current here, I'll be like 0. Why? Capacitor. Current here, same current, E by 2R. So E by 2R here, E by 2R here, E by 2R here. Everywhere E by 2R current is flowing or no current is flowing. So we came to know everything about the current. Now let's talk about the charges. Now think about it. Just think about it. Can I say this point's potential, this point's potential, this point's potential all are same? Yes, because they are connected using a wire. Now this point's potential and this point's potential is also the same. Why? There is no resistor in between. Same. And there is a wire here. That means this point's potential is also the same. Interesting fact is that across the capacitor, the potential difference is 0 because this point as well as this point are at the same potential. So if you ask me what is the voltage difference, I will say it is 0 volts. It's 0. So what is the charge on it? The charge on that capacitor is also going to be 0. No voltage, no charge. Excellent. Now let's talk about this capacitor. Okay, one side it has a voltage of E. You can see all these points have a voltage of, let's say, E. Okay, but this point, I think it's connected directly over here. Okay, so I think it will have some voltage difference. So how much voltage difference does this capacitor have? It will have the same voltage difference as that of the resistor. Look at it. Same voltage difference as that of the resistor. How much is the voltage difference across a resistor, guys? Remember, it is I into R. That's the voltage difference. But what is the value of I? I just calculated the value of I. It was E by 2R. Check it out. It was E by 2R. So just use I is equal to E by 2R. What is the voltage difference that you are going to get? R cancels. You will get it as E by 2. So can I say the voltage drop across that capacitance is E by 2? Is that understood, everyone? The voltage difference is E by 2. I hope this is very clear. Current was already found out. So whatever voltage is there is IR. That's Ohm's law. Same voltage drop will be there here. and that's E by 2. So what will be the charge on this capacitor? C into voltage drop, which is E by 2. That's the answer. That's it. That's it, guys. As simple as that. So if you go step by step, you will get it. Just use my method now, marking the potentials. Mark the potentials. See which points have same potential by some logic, and if some point has different potential, you can show it by some different color or different symbol. And that way you can easily solve the problem. So use my method of marking the potentials. It will make it very simple. Your life will be very easy. Clear? Very easy, guys. Alrighty. Let's go to the next question. It's slightly more tougher than this, but trust me, now that you know how to solve it, it looks easy and you will see that. Alrighty, come on guys, keep the josh high, and if you have not yet liked the video, do hit that like button, and if you are a new user, do not forget that if you want to study more such things under me, you have to hit that subscribe button down there. So please go ahead, it's free, just become a member of our family by hitting subscribe, and do not forget to smash that like button down there. Alright, clearo, perfecto. Next question, guys, going to come up on your screen, but before that, let me tell you about Kirchhoff's voltage law and current law, which I had already mentioned, but just keeping capacitor in mind, how will things marginally change? Well, only the symbols will change, that's it. So imagine there is some complex loop and you have assumed some current to be I1, let's say this resistance to be R1, let's say this resistance to be R2, let's say this current to be, let's say I2, and maybe here there is some current I3, I don't know, and here there cannot be any current. Remember, there is a capacitor, and on this capacitor of capacitance C1, all right, there is some charge, let's say Q1 and minus Q1. Okay, so that's the thing. Now first thing, choose a loop. So let's say I start from here, A, then I go to B, then I go to C, and then I go to D, and then I come back to A. So my loop is A, B, C, D, A. How will my Kirchhoff's law, voltage law look like? Carefully observe this now. From A to B, I am going in the direction of current across a resistor. So in the resistor, the voltage drops when the current flows through it. So the voltage should drop. So minus I1, and there will be R1. So drop is I1, R1. From B to C, you are going opposite to the direction of current. So actually speaking, the voltage should drop like this. So when you go from here to here, the voltage should climb up. So it should be plus. So it should be plus I2, R2. That's how the sign convention goes. Here, although there is a current, but there is no resistor to drop it. So there should be a zero term over there, just to signify there was no drop from the branch C to D. From D to A, think about it, you are going from the negatively charged plate to the positively charged plate. So from minus to plus, you are making a jump, you are making a climb. So it should be plus. And what is the voltage across a capacitor? Think about it. Q is equal to CV. So V will be Q divided by C. That's it. So it will be Q divided by C, and that should be equal to 0. Not QC. V is Q by C, remember that. Okay, Saurabh? I hope this is clear. Now you got an idea of how to apply Kirchhoff's law in case of capacitors. So just assume the charges and then write your equation. Wherever the voltage increases, put a plus. Wherever the voltage decreases, put a minus. That's it. Okay? Are you guys confident? Shall we solve problems, or you want to do it for any other loop over here? Do you want me to do it for any other loop? If you want me to, let me know. Else I'll just go ahead now. If you guys are confident, we'll start doing some problems. Shall we go ahead? Understood, everyone? Let me know, please, in the chat box. Okay. Come on, guys. I want to interact with you. Alrighty. Come on, quickly. Okay. Chalo, let's go ahead then. Chalo, let's do the problem. Okay, so looks like a crazy problem, but hold on, we are going to see it. Find the potential of this point, find the current shown by the ammeter and the charge on these capacitors. So that's the question. Basically, you have to find out everything. So let's get to the point. So let's try to understand what and all is there in the problem. There are resistors, there is a battery, there is a ground point, there are two capacitors as well, ammeter as well. Now let's start marking the potentials of whichever points we know. Okay, now this is 30 volts. Naturally, this will be also 30 volts. Correct? If this is 30, this will be also 30. But this won't be 30, guys. There is a resistor in between. And this is ground. That means this point over here should be 0 volts. Ground means 0 volts. Alright, you have connected it to the earth. That is the earthing symbol. So the potential over there should be 0. Nowhere else I know the potentials. So I cannot do anything about it. Just leave it across. So let me call this point as Y in case I might need it maybe later on. And what else? Okay. Now let's assume the currents. Be careful. Whichever part or branch has capacitors, no current will flow through it. No current will flow through it. So think about it. There should be no current here. There should be no current here. If there is no current here and here, can this branch even have current? Think about it. Because even if it has current, where will it go? Because these two branches are not going to allow the current to flow. So the current across 10 ohm will be 0. So this is 0. Understand? No current will flow, and there is no current here also, and there is no current here also. So the current here is 0. So it does not flow in any direction. Then, if this is understood, think because this capacitor is in series with this 20 ohm resistor, no current can flow in this resistor also. So in fact, this is 0, this is 0 direction wise. Okay? No current flows, guys, no matter where you go. So I'm just showing this square like symbol just so that you know there is no current in all these branches whatsoever. No current here. Now things have become very simple now. Guys, so many branches are eliminated. So think about it. Yes, it is the open point 17S. Remember, I just told you that. So it is like an open switch, so no current will flow. So the only way current can flow is like this. That's it. There is no other way current can flow. And if my direction is wrong, automatically my answer will come out to be negative. But I have a feeling current will go from higher potential to lower potential. So it's better at the start only that we assume the directions correctly. So most likely the current is going to flow like this, like this, like this, and like this, and back into the ground. So the current is going to go from 30 volts to 0 volts, and that current is I. Now, who and all are coming on the way? There is a resistor, ammeter, battery, resistor, and nothing else. So what do we do? Start from 30 volts and go till 0 volts. That's it. Start from 30 volts and go till 0 volts. Come on, guys. 30. So what I'm trying to do is, I'm kind of using Kirchhoff's law, but I'm starting from a point and going to another point, not coming back over here. So when I add those potentials, starting from one point, if I keep adding the potentials, eventually I'll reach to the potential of the final point, which is going to be 0 volts. So let's do this. 30 is the first point. Here the voltage is going to get dropped by how much? Minus I into 5 IR. That's the drop. Ammeter is of no use, guys. It's zero resistance. Remember, ammeters are ideal ammeters are zero resistance, so there is no drop across the ammeter. Then this is a battery. I'm going from high to low voltage, so it is minus 10 volts drop, and across this resistor also there is a drop of I into 5. All right, and eventually I reach the final destination whose potential is 0. So what this equation says is, this is my starting point. This is my starting point, okay, and this is my ending point's potential, and in between these are the things that I encounter. Some may drop, some may increase, doesn't matter. Some may not create any change. So you keep adding them, you will reach to the ending potential. So what will happen, guys? Think about it. 30 minus 10 is 20. 5i minus 5i, 10i. So take it to the other side, it will become 10i like this. So I will become 2 amperes. So I have found out at least one answer. I is 2 amperes. Now comes the next. Yes, consider the ammeter as ideal. Okay, Ankit, I will be telling everything. You can also make notes even after the class. Let me tell you, please pay attention because this is problem. For theory, I will give you some time, but just observe now. Say, observe one more thing, guys. There is no current in this 20 ohm branch. If there is no current, what will be the voltage drop? Nothing. No voltage drop. IR will be 0. So if this is 0 volts, see if you understand this. This point should also be 0 volts. No current, so no potential drop. Very nice concepts that you are learning here. You should be proud of yourself. And this point we know is 30 volts. This branch is not having any current. So guys, I have a feeling now I just have probably, you know, 2 capacitors in series. Think about it. This is nothing but 2 capacitors in series. One is 2 farad, another one is how many farads? 4 farads. There are 2 capacitors in series. Do you see that? Do you see that? This has become so simple problem now. If you keep solving it, you get the hang of it. Initially it looked very difficult. So if that's the situation, guys, aren't the capacitances in the ratio of 1:2? So the voltage drops across them. The voltage drop across them should be in the ratio of 2:1. So how do you divide 30 volts in the ratio of 2:1? Think about it. Divide 30 volts in the ratio of 2:1. Come on, think about it. What will it be? 30 volts divided in the ratio of 2:1 means divide 30 volts into 3 parts, guys. 2 plus 1 is 3. 10, 10 and 10. Now take 2 parts of 30, which will be 20 volts. And remaining 1 part over here. So that's how 2:1 is what you will get. Very, very simple. Now that you know it is 20 and 10, you also know the charges. So guys, what are the charges on both the capacitor? Both capacitors have the same charge, C into V. So 2 into 20, which is nothing but 40. All right, 40 and coulombs. That's the answer for both the capacitors. We got that as well. We got that as well. Interesting. Last point remaining is, what is the potential of this point X? What is the potential of this point X? Guys, can you immediately tell me the answer? This point has 0 volts. From here to here, the voltage increased by 10. So what should be the potential of point X? Can you quickly tell me? Can you quickly tell me? Come on, think about it. This point X, how much potential will it have? This is 0. The drop across 4 farad is 10 volts. Come on, think about it. This is 10 volts, remember? All right, come on. Yes, it should be 10 volts. Excellent, guys. See, you guys solved it, yaar. You guys solved it with me. Very good. Very good. That's why you should keep coming here, because then you will get confidence. So many things we found out, and this can be a proper good level question. Many people will leave the question looking at the diagram, but you are not going to do that because you have attended my sessions. Very good, very good. Not minus 10, 10 volts. Yeah, because the potential is increasing from here to here to here. So 0 plus 10 and 10 plus 20 will give you 30. That's how it is. Excellent. Very good, very good. Now, let's solve this question as well. No problem. We'll solve this question also. Not a difficult question. You will solve it. and I'm pretty sure we are going to solve it together, guys, and you will see how simple the answer is. Let's do this. Are you guys ready? Don't let the juice die. Don't get disappointed. Don't get scared of capacitors ever after this session, because this session is meant to make sure that I am going to give you that kickstart to solve those capacitor related problems. Very good, guys. Let's get going. Now, first thing that we should do is get rid of that capacitor which is there, because nothing will happen across that capacitor. It's an open switch. Along with this capacitor, there will be one more casualty. This capacitor though will go away. Apart from that, this resistor bechara will also go away because there is no current in that branch. So I will redraw that circuit, and this time when I'm drawing, let's draw it like this. Okay, 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 and this battery out here. Alrighty, that's it. I believe this is how many volts? 10 volts. So this was R, this is R, this is R, and this is R. Hey, this looks like a simple circuit to me. Guys, did you just realize it's nothing but a very simple circuit? What will happen? Oh, think about it, guys. These two resistors are in series, correct? Their combination is in parallel. So basically, it's nothing but 2R and R. So 2R into R divided by 2R plus R. How much will it be? It will be 2R by 3. So 2R by 3. So that is the equivalent combination of this, guys. So you will have a resistance of 2R by 3, and in series you will have one more resistance of R and a battery of 10 volts. Now this 2R by 3 and R, they are also in series. Come on, guys, let me know. Are you able to see that? So you can see that they are also in series. So what will happen? You can just write it as one single battery and equivalent resistance. 2 by 3 plus 1, 3 plus 2, 5. So it will become 5R by 3. That's the equivalent resistance. I will need it to solve the problem. How and why? You are going to see that now. Now, what will be the current in the circuit? This current will be V by R, which is 5R by 3. 10 and 5 gets cancelled, 3 goes on the top, gets multiplied by 2. So I believe it should be 6 divided by R. If this is 6 divided by R, the same current should flow here also. This current should also be, think about it, 6 divided by R. Now, think about it here. Well, at this location the current is 6 by R. Here also the current is 6 by R. Here also it is 6 by R. But here it will not be the same. Why? It has to get divided, guys. Divided. Think about it, parallel. And I will need that value. How do I do it? Well, think about it. Here the resistance is 2R. Here the resistance is R. So I need to divide 6 by R in the ratio of 1:2. If I have to divide 6 by R in the ratio of 1:2, first add 1 plus 2. It will become 3. So make 3 parts of 6 by R. So if you make 3 parts of 6 by R, what will happen? You will get 6 by 3R, 6 by 3R, and 6 by 3R. Now what is 6 by 3R? Think about it. It is nothing but 2 by R. So 2 by R, 2 by R, and 2 by R. So those are the 3 parts of 6 by R. In the higher resistance branch, how much current will flow, guys? Less current. So only 2 by R will flow. 2 by R. In the lower resistance branch, the remaining current will flow. How much is 2 plus 2? 4 by R. That's how the currents get divided. I hope I'm making things look very simple to you now. I mean, I'm making it look as if I'm teaching a 6-year-old, but it's okay. I mean, you should understand this properly. Now, because no teacher I've seen they teach how to divide in the ratios and all that, I want to do it because I want you to get that confidence, guys. Alrighty. Now here is the thing. What is the question? We forgot the question only. What is the question? The potential difference across the capacitor. Acha. Oh, by the way, this was 6 by R. So if I want to find the potential difference across the capacitor, that means what is the potential difference from this point to this point, from A to B. Acha. So let's start, guys. Let's go from A to B. So it will become VA. The first thing I encounter is this resistance. So potential will drop. How much will it drop? I, current is 2 by R, into resistance, which is R itself. So the current through this branch was I, which was 2 by R, into resistance. From here to here, the current is different. How much is the current? 6 by R. So 6 by R into the resistance. And eventually, where do I reach? I reach point B. Now think about it. That's the potential at point B. Remember, always start from one point, see whatever you get on the way, and eventually get the potential at the next point. So you will get VA. Now this will become -2 -6. Oh, RR also goes. You will get VA minus 8 is equal to VB. Acha. So I'll get VA minus VB is 8 volts. That's the answer. Brilliant, guys. This is the final answer. That's it. I hope this is very clear now. I can't explain more simpler than this. This is the best way to solve the problem, and all this has to happen within 1.5 minutes. And how that will happen? When you solve a lot of questions. Initially, I know you'll be like, sir, you're kidding, you're joking. How can we solve this problem in 1.5 minutes? Guys, it is possible. I'm explaining to you slowly, that's why it took some time. But remember, in the final exam, you're going to solve this because you're going to practice a lot of questions. Okay? So, I don't think you will be scared after this to solve any capacitor questions, guys. Okay. Now, let me tell you some more things. And I'm going to solve one more amazing question, guys. Yes, done. Let's do that trick. By the way, use of symmetry. Now you might get scared looking at, oh my god, just like one capacitor wasn't enough and now we have a hexagon and so many capacitors. Do you remember the trick of symmetry I told you? The trick of symmetry is, first check the 2 points across which you want to find the capacitance. Join that line and see the perpendicular bisector and see if there is any symmetry. Just see if there is any symmetry. Yes, whatever is there on this side is there on that side. And if there is a symmetry, that's it. Symmetry means whatever is there on mirror images. Alright, so there is a mirror image. So that's it. So that mirror becomes the equipotential point. Means this point, and this point all are equipotential, guys. They all are equipotential. Yes, some people are remembering benzene, chemistry, yaad aa gaya. Alrighty. So if they are equipotential, just separate them out and believe me, you can convert them into this circuit. Because the intermediate circuit will look something like this, guys. You will have that capacitor over here and this capacitor here and this capacitor here like this in the top branch. Okay. And this capacitor like this, I believe. It will not be connected anymore. And another capacitor here. And then again something like this, like this, like this. They are not joined. Please understand that. So they are disconnected now. And these two are in series. So are these two are in series. So you can convert them as C by 2, and now it becomes a simple series and parallel problem. Yes, it's something like the concept of Wheatstone, something like that. But remember, this capacitor, do not break it out, because in Wheatstones what happens, whatever is there on the middle gets cancelled out. But here this capacitor is still there because you cannot break that capacitor. So, but the good thing is this capacitor comes in parallel with this capacitance, so you can now solve it very easily. Okay, so that's how you solve this question. I hope this is clear now. You can solve this question once you know how to break it down into simple series parallel circuit problem. Now let's think about some symmetry, but for a different question. Let's do this question, guys. Very, very interesting question. To find the capacitance of the cube, you will be like, sir, we have done this question. Yes, we have done this question in resistance. Then you'll be like, sir, it's the same thing. But pay careful attention, carefully observe this diagram, and you will realize the points are slightly different. In the resistance problem, we had found out equivalent between this point and this point. Today, we are going to find it for diagonally opposite points. We are going to find it for diagonally opposite points. I know it looks little scary, but don't worry, I am there. Just say all is well. All right. So let's see how to solve this question. And let me get my board up. So hold on. Okay, so now we have a cube. And oops. Okay, so this is my point A and this is my point B. So these are the 2 points across which I need to find the capacitance, guys. I need to find the capacitance. The method is the same. Now, see if there is some kind of a symmetry out here, and I feel that there is a symmetry. I don't know whether you can see it. The points are A and B, not here and here. They are not on the same plane. They are, one is here, one is on the top. I feel if you join both of them, all right, if you join both of them, you can see that there is a very beautiful symmetry as you go like that. There's a very beautiful symmetry out there. Now, what is that beautiful symmetry, guys? See, whatever comes from this point will get divided equally. Whatever comes from this point will get divided equally into these 3 branches. So let me mark those branches for your simplicity. So this is AB. Let's say I call it P, Q, R. And this is S, T, U. That's it. So these are the branches. So think about it. In the branch AR, in the branch AP, and in the branch AS, they are symmetric. You can visualize that there is a cube, and that yellow line, that orangish line is like the axis, and you can spin that cube along that axis, and you can see that you can always rotate the cube, and this side will fall here, that side will fall here, and so on and so forth. So they are easily replaceable with each other. You can just turn that cube, visualize it. I know it's slightly difficult, but you can do that. No problem, Sushma. All right. So think about it. If at all there is a charge which comes from here, Q, from the external circuit, and the charge which leaves from this point obviously also has to be Q, obviously. So this Q is going to get divided into 3 branches equally as Q by 3, Q by 3, and Q by 3. Think about it. The charges are going to get divided equally into these 3 branches, Q by 3, Q by 3, Q by 3. Is that okay? If there is a battery connected, Q charge is being supplied, it distributes the charges equally. Now, yes, you're going to learn all the alphabets. Very good. Now, when that charge comes here, this Q by 3 charge comes here, think about it. Now, again, it has 2 options. Again, it has 2 options, but both these options are equal. I hope you can see that. Both the options are equal. So that Q by 3, guys, is going to get further divided. It's going to get further divided into half of that. What is half of Q by 3? Half of Q by 3 is nothing but Q by 6. So this will be Q by 6 and this will be also Q by 6. That's it. This will be also Q by 6. And the same thing is also going to happen here. Once from A to R, the charge Q by 3 is going to come. it's going to get equally divided into two branches, and same thing from A to P, it's also again going to equally divide itself into two branches. Now, like, sir, it's so complicated. Now, what will happen next? Guys, nothing is going to happen next. It's simple. You know what is going to happen next? Guys, at point B, all the charges have to collect back. They have to collect back themselves. Think about it. If this Q was reversed at point B, they will be equally divided into all these three branches. So from all the three branches which are symmetric, the charges should be again Q by 3, Q by 3 and Q by 3. I hope you can visualize that. This will be also Q by 3. So very, very important, guys. See how the charges are getting, how the charges are getting distributed. See, from T to B, U to B and Q to B, understand the charges are getting equally divided because of symmetry. They are all symmetric lines. You can rotate that cube. You can see when you rotate that TB line will come onto BQ, and that UB line will come onto TB, and that BQ line will go onto UB. You can rotate it. It's the same thing. There is no difference in them. Now, you'll be like, sir, okay, we did all this. Now what to do? Please tell us. Okay, it's simple. You know what has to be done? Go from any point, let's say A, via any path, and go to the last point from A to B. Just go from point A to B. So from point A, if you start and go till point B, just add the potentials on the way. Think about the formula. Q was CV. Remember, this was the formula that we always use for charge on the capacitor. From here to here, what is the potential difference that you will get? From here to here, what is the potential difference? Charge by C. So what is the charge? The charge is Q by 3 upon C. So from A to P, what is the potential difference I'll get? Q by C. But what is Q? Q by 3. Okay. Now from point P, you can go either this way or you can also go like this. It's up to you, however you want. So let's say I go like this. Remember, from P to Q, the charge is Q by 6. All right. Maybe in case that color is not so visible, so I'm writing it. From P to Q, what will be the voltage difference? Again, charge, which is Q by 6, by the capacitance over there. Remember, every branch had a capacitor. And from this point to this point, please don't get confused with this symbol. This was the alphabet Q, not the charge Q. So don't get confused. From Q to point B, the voltage difference will be again Q by 3 and C. And what will you get? You will get the voltage at point B, guys. You will get the voltage at point B. Now you'll be like, sir, what are we trying to do over here? You will see. So it will become VA minus VB. So VB has been brought here. Take all these three terms there. You will have Q by C common, and you will have 1 by 3 plus 1 by 6 plus 1 by 3 over here. Now this is nothing but voltage between A and B. Voltage between A and B. Now this will become Q by C. Now what is 1 by 3 plus 1 by 6 plus 1 by 3? 2 plus 1 plus 2. So it will become 5. 5 by 6. Just check this out. It will become 5 by 6. 5 by 6. I hope this is clear. Now comes the best part. Q is equal to 6C by 5 into VAB. You know what this equation means? This means that had you given this charge to a capacitor with the same voltage difference AB, then that capacitance will be 6C by 5. So that is the equivalent capacitance. That's it. Problem solved. Done. Done. 6C by 5. Understood this, guys? How this problem is done? Very easy. After you understand how it is done, that's all. What a beautiful problem. So I'll just repeat what happened. Assume some charge. So to solve these kind of problems, assume some charge has come. Assume that it gets distributed, and look at the symmetry of distribution, because there were three branches. here, there and here. So that's why it got divided into 3 parts. Now whenever it comes here, this point P has 2 equal choices. So half of q by 3 is q by 6. So q by 6 will go here as well as here. And this last branch, again, everything is going to collect itself. From here also q by 6, here also q by 6. So it will become q by 3 and back over here. And now start from the initial to the final point and somehow show it is a multiple of something into the voltage. That something will be your equivalent capacitance. Okay, I hope this is clear. All those of you who had got stuck anywhere in between, I just quickly revise through it. And the rest all is mathematics. Very, very important problem. Yes, all is well has worked. So these are our stars of our last session, capacitor session 1. Aishwarya, Saurabh, Science Priya, Ankit, who have posted the answers of the previous session. The homework doesn't matter whether it is correct or wrong, but you guys have attempted it well. Very good, very good, and keep it up guys, very good. And these are your homework problems for today. This is first question. You can take a screenshot of the question, potential difference across the capacitor. You can do it very easily. Alright, this is your first question. And remember, I had told you about the infinite capacitors. So that's your second question. These are your 2 questions for homework guys. You can take a screenshot of this as well. And this was your previous question. Okay, so these are your 2 questions and I'll be posting the answers in the Telegram group. The solutions etc. will be posting in the Telegram group. So start solving it immediately. Post the answers in the comment box guys. Very, very important. Only then you can become a star. So this is our official Telegram group where I'll be posting all the solutions of the homework questions. And remember, the crash course is starting again this Monday for all the 12th and the dropper students with 120 live sessions, 2-way interactions and doubt solving from morning till night along with class teachers. After the class, you will have subject experts and 20 test series where you will get all India ranks, analysis reports and so many other things in this crash course. The link is in the description box below. Do not forget to check it out and use the coupon code SHCC. You can share the coupon code and the link with anyone who you think will be needing it. And do not forget to hit the like button and the subscribe button. If you are a new user, definitely you should hit the subscribe button and like it because I have done a lot of things to teach you guys. Alright, so that's a little bit of thing that you can do out here. Thank you very much guys. And tomorrow I forgot to tell you one very important thing guys. Special session. Guess what the special session is? Does reality exist if you do not see it? Does reality exist if you do not see it? That's the special session tomorrow at 7 p.m. Get your friends along, get all your college friends, get all your school friends along. It is going to be a fun session. You're going to love it. Alright, so see you guys tomorrow at 7 p.m. Bye bye, tada, take care. This was Shreyas here, your master teacher for physics.